step reflecting our commitment to integration into the international scientific community and promotion academic openness. Our task is to review the submitted work thoroughly, evaluate its scientific novelty, the degree of independence, the validity of the constitution, and the overall compliance of the dissertation with the standards required for works of this level. The dissertation council consists of 4 permanent members, 3 temporary members, and 2 reviewers. List of participants. Pinkov Fyodor Mikhailovich, Deputy Chairman, Doctor of Physical and Math Sciences, Professor. Буртибаев Dasturullah, Doctor of Physical and Math Sciences, Professor. Zaripova Yulia Ayratovna, Scientific Secretary, PhD. Nurmukhambetova Alia, Reviewer, PhD, Postdoctoral Scholar of Energy Cosmos Laboratory, Project Group, Nazarbayev University, Astana. Timirbayev Azamat, Reviewer, PhD, Senior Lecturer of the Department of Nuclear Physics, New Materials and Technologies, Gumilev Eurasian National University, Astana. Vasilevsky Viktor Semyonovich, Foreign Scientist, Temporary Member, Doctor of Physical and Math Sciences, Leading Researcher at the Bogolyubov Institute for Theoretical Physics, Kiev, Ukraine. Lebedev Igor, Temporary Member, Doctor of Physical and Math Sciences, Head of Laboratory of Nuclear Physics and Radiation Ecology, Institute Physics and Technology, Almaty, and Kabdrahima Gaukhar, Temporary Member, PhD, Dean of the Graduate School of Education, Shakarim University, Semey, Kazakhstan. All members of the dissertation councils are present. 2 temporary members of the council are attending the meeting online, as well as the 2 official reviewers. The remaining members are attending in person. A quorum is present to begin the work of the dissertation council. There is proposal to begin in meeting of the dissertation council. Are there any objections? No? Thank you. The meeting of the dissertation council is declared open. On the agenda is the defense of the dissertation by Елеушева Б.М. Maratovna, submitted for the degree of Doctors of Philosophy, PhD, in the educational program AD 05308, Nuclear Physics, on the topic Radiative Capture Reaction on Light Nuclei in Stellar and Interstellar Plasma. The research was conducted at the Department of Theoretical and Nuclear Physics, Faculty of Physics and Technology, Al-Farabi, Kazakh National University. Scientific advisors, local scientific advisor, Doctor of Physical and Mathematical Sciences, Professor, Al-Farabi, Kazakh National University, Буркова Natalia Alexandrovna. Foreign scientist, scientific advisor, Doctor of Physical and Mathematical Sciences, PhD, Professor of Physics, City University of New York. Kizarashvili Roman Yakovlevich. Official reviewers, Nurmukhambetova Alia, PhD, Postdoctoral Scholar of Energy Cosmos Laboratory Project Group, Nazarbayev University, Astana, Kazakhstan, and Timirbayev Azamat, PhD, Senior Lecturer at the Department of Nuclear Physics, New Materials and Technologies, Gumilev Eurasian National University, Astana, Kazakhstan. The dissertation is being defended for the first time. All members of the dissertation council have received and materials related to the work. Are there any comments or objects to the agenda from the members of the dissertation council? No? Thank you. The agenda is approved. We keenly ask the members of the dissertation council participated online to keep their cameras on as the defense is being recorded and streamed online. To present the candidate's personal file, the floor is given to the scientific secretary of the dissertation council, Zaripa Yulia. Please.
Okay. Thank you very much. Please, Azamat Aliyevich, can you rename your account in Zoom by your name and your surname? Because it's just пользователь Zoom. Can you please rename? We can't hear you. We can't hear you.
Unmute yourself.
No, I mean, I'll try to do it, but I don't know how to do this.
Okay, please try it. Thank you. Oh, dear members of the Dissertation Council, allow me to present the personal file of the PhD candidate Елеушева Б.М. Maratovna. Елеушева Б.М. was born on February 23rd, 1995 in Taras and holds citizenship of the Republic of Kazakhstan. In 2018, she completed her undergraduate studies at Al-Farabi Kazakh National University with a bachelor degree in 5B 060500 nuclear physics. In 2020, Master of Natural Science in Specialty 6M 060500 nuclear physics, also at the Al-Farabi Kazakh National University. From 2021 to 2024, she studied at the PG program, educational program C8D 05308 nuclear physics at Al-Farabi Kazakh National University. Елеушева Б.М. Maratovna began her professional career in 2021 at the Fesenkov Astrophysical Institute, Almaty, Kazakhstan, where she currently employed as a research scientist. Her total work experience is 4 years. The dissertation entitled Radiative Capture Reaction on Light Nuclei in Stellar and Interstellar Plasma was carried out at the Department of Theoretical and Nuclear Physics, Al-Farabi Kazakh National University. This work has been recommended for defense based on the decision of extended meeting of the Department of Theoretical and Nuclear Physics, protocol number 6 from October 28, 2024. On the topic of the research, 4 publications have been published in scientific journals, which is indexed in the Scopus and Web of Science database. 1 article in Frontiers in Astronomy and Space Science with percentile 55 and Web of Science quartile Q2, and 3 articles in Chinese Physics S with percentile 84 quartile 1. The following documents are included in the candidate's personal file. It's an application, addresses to chairman of the board, Rector of Al-Farabi Kazakh National University regarding the acceptance and sending the dissertation for defense. The dissertation work in hardcover and on electronic media. Reviews from local and foreign scientific advisors certified at the advisor's place of work. The abstracts in 3 languages. An extract from the protocol of extended meeting of the department from where the dissertation was carried out with a positive recommendation for defense, approved by the member of the board, vice rector of scientific innovative activities of Al-Farabi Kazakh National University, a transcript of the completion of the doctoral education program, information about the doctoral candidate, personal file from the Human Resource Department of Al-Farabi Kazakh National University certified at the place of the registration, reviews from the official reviewers certified at the reviewer's place of work, a certified from the National Center of Science and Technology Evaluation, confirmed plagiarism check A certificate from the Scientific Laboratory of Al-Farabi Kazakh National University confirming the submission of the dissertation and abstract. Extract from the protocols of the Academic Council meeting of Al-Farabi Kazakh National University regarding the approval of dissertation topic and scientific advisors. Order of the chairman of the board, director of Al-Farabi Kazakh National University on sending the dissertation for defense. A list of scientific works certified by the scientific secretary of the Faculty of Physics and Technology at Al-Farabi Kazakh National University with their copies, and the conclusion of University Local Aid Committee. The materials of dissertation submitted by the candidate Елеушева Бадигуль Маратовна complied with the approved guidelines for preparing a dissertation for defense. Thank you for your attention.
Thank you, Yulia. Dear colleagues, do you have any question for the scientific secretary? Questions? Thank you. If there are not questions, the floor is given to the candidate. Елеушева Бадигуль Маратовна has 20 minutes to present the main content of her dissertation research. Please.
Thank you so much. Hello, everyone. My name is Елеушева Бадигуль. I am doctoral student of Al-Farabi Kazakh National University, the Faculty of Physics and Technology, Department of Theoretical and Nuclear Physics. The topic of my dissertation work today is a radiative capture reaction on light nuclei in stellar and interstellar plasma. My local scientific advisor is Professor Буркова Natalia Alexandrovna. My foreign scientific advisor is Professor Kizirashvili Roman Yakovlevich. The purpose of my work is a model calculation of reaction rates of radiative neutron capture on lithium 8, boron 9, beryllium 9 and boron 13 isotopes, and also the proton capture on nitrogen 15. The research objectives is following: to calculate the total cross-section and reaction rate for the lithium, beryllium and boron isotopes, and also re-estimate the astrophysical S factor for the nitrogen 15. And we need to evaluate the impact of this astrophysical S factor to the reaction rate. On the base of implemented research, there are 3 defense of provision have been formulated. The first one, the first defense of provision formulated related to the lithium-8 reaction. We found 2 criteria to evaluate this reaction rate, narrow down to a range of reaction rate and constrain the a choice of asymptotic constants. It means that it can be the thermal values of the thermal cross-section and also the correlation between the reaction rate order and threshold energy at low temperatures for the following lithium isotopes. Sorry. The second defense of provision related to the beryllium 9. Here we calculate the total cross-section and also partial cross-section in modified potential cluster model in energy range from 10⁻⁵ to 5 MeV. And also in our consideration, we included 5 resonances, and we estimate this impact of these resonances to the total cross-section and also to the reaction rate. The inclusion of resonances to the reaction rate give us the factor rising T9 smaller than 1.45 times with in correlation with modern research, such kind of like Moore and Wallner. The third defense of provision correlate with the boron 13 isotope, and we also calculate the total cross-section in energy range from 10⁻² up to 5 MeV in modified potential cluster model. And we here can say that it can be proposed to the new experimental measurement of Isolde. The present results of reaction rate can be also substantiate the role in the boron carbon nitrogen chain. And here we can say that this is a not breakpoint of boron sequences. Let me turn to some general physics concept. Here in section 1, I present the main role of modified potential cluster model among the direct and indirect methods of evaluation radiative capture reaction. Here, important to note that all the present calculation is based on application of modified potential cluster model. MPCM, modified potential cluster model, it's important to stress that this model based on the asymptotic normalization coefficient, charge and matter radii, gamma width, and channel binding energy. Here you can see it. We know that all these parameters are very important in construction two-body potential, which are the central part of the Schrödinger equation solution. Let's turn to the next section and turn to the elements of formalism. Here you can see the formula. To calculate the total cross-section of radiative capture reaction, we use this well-known formula. And here the important part of this formula is overlapping integral. And as I said in previous slides, all the fixed parameters, which I mentioned above, under the Schrödinger equation here. And also we need to say that here PG square, as you can see, it's algebraic part, which corresponds which provides the corresponding selection rule of multiple transition. It can be electrical, magnetic, of course. Let me turn to the next section. The next section is deals with the formation of primordial lithium-8. The importance of this reaction in nuclear astrophysics because of the well-known 8 gap in creation of post-BBM period, in creation of element in post-BBM period. On the other side, if you can see on the graph, here we see the total cross-section of this reaction. And as we can see, the measurements of the total cross-section is really dramatic. We only have 2 experimental points, which are measured by 2 different methods by using the uranium and plutonium heavy nuclei. Here we also can say that column dissociation reaction rate have been calculated, and then the total cross-section converted into the radiative capture cross-section. But what is important here? This is not direct for this integration. So there is some specialties which are coming from the virtual proton in this experiment. You can say that here we have a large air bus between these 2 experimental points. And also on the graph, you can see the 2 groups of calculation. One of them, it's theoretical calculation. One of them is McCracken, and second one is Dong. As you can see, there are a lot of big essential difference between these theoretical approaches. And our present results of the total cross-section are given on this graph as a pink pale band. Band is coming due to the variation of asymptotic normalization coefficient. You can see here this CW upper set and lower set. On the base of the calculated total cross-section, we also calculated the reaction rate for the lithium-8 reaction. And here the great difference between reaction rates appears at T9 smaller than 1. What does it mean? Here we have a question. Which one we can believe? Ab initio, Dong, or present results? Let me turn to the criteria which give us the possibility to find the reliable one. We analyze The results of the reaction rates of lithium isotopes in one and the same model, in modified potential cluster model, and find the regularity that which correlate between the binding channel energy and the reaction rate. It means that the higher channel binding energy, the higher reaction rate. This regularity also exists in boron isotopes and also in the nitrogen isotopes. Let's turn to the conclusion and prospects. Here we calculate the total cross-section reaction rate, and also we approved the minor role of the gamma-1 process and the transition, and proved that the transition to the ground states are dominant. We found two criteria for evaluation of reaction rate for this reaction, and which the second criteria, as I said before, correlate with the thermal cross-section and correlation between the binding threshold energy and the reaction rate order. And this conclusion correlate with defense of provision 1. Let me turn to the next section, which deals with the radiative neutron capture of beryllium-9. Here you can see the spectrum level of the beryllium-9 and guides further calculations. The radiative neutron capture of beryllium-9 is much more complete than the previous one with the lithium. It provides with the razor detailed measurements. That's why in our consideration consists 1 ground, 5 excited, and 5 resonances are taken into account. And for today, this is a most complete consideration for this reaction in model approach, of course. As illustration of above calculation, you can see here the total cross-section of the beryllium-9, which calculated in energy range from the 10⁻⁵ up to 5 MeV in modified potential cluster model. And also you can see here the thermal cross-section and resonance structure in this cross-section. Comparing the ground states partial cross-section and to the transition to the first and the second excited states gives the essential input in total cross-section. Here we can say that our calculated thermal cross-section are in a good agreement with other experiments. Here you can see the results of the reaction rates on the based of the calculated cross-section. We also calculate the reaction rate, and here we can assume that at T9 equal 1, it seems like the reaction rate's close to constant, but it's not constant. And then appear T9's bigger than 1, the reaction rate started to rising. And this is a signature of the resonances we're taking into account in our consideration. The total reaction rate approximated by analytical expression in this bracket. This graph illustrates the comparison of total reaction rate of radiative neutron capture on beryllium-9 in different model approach. Here you can see the other model approach, more Wallner, and our results here we present as a bold one, including resonances, and continue one present red is without resonances. The comparison of resonant region with non-resonance region shows the rising of the total reaction rate from the following T9. We also we also in present calculation obtained the value of the thermal cross-section, as I said in the previous slide. Let me turn to the conclusion and prospects for the beryllium-9. We found, we calculate the partial and total cross-section in the energy range from 10⁻5 up to 5 MeV by using the modified potential cluster model. We also calculate the thermal cross-section, which are in a good agreement with other experimental data. The inclusion of resonance shows the impact of corresponding reaction rates with a factor rising 4-5 times at T9 smaller than 1 in comparison with the modern research, Wallner and more. And this conclusion correlate with defense of provision too. The next section deals with the proposal for the radiative neutron capture of boron isotopes. And here the situation with the radiative neutron capture of boron 13 I declared as a proposal for the future investigation because there is no any, it was not considered in literature before, there is no any model calculation for this reaction. This radiative neutron capture of boron 13 plays a key role in these sequences. And we have a question here. Should we break down the boron sequence and switch on the carbon sequence? To answer to this question, let me turn to our results. This is a result of the total cross-section of boron 13 in to the ground state. And here we calculated in the ultra low 10⁻5 up to 5 MeV. Partial, we also calculate the partial cross section, which one reveals with the resonance, and the histogram of the is very preliminary experimental estimation of this consideration. And as I said, in a previous lithium slides, there are again, we have a correlation between channel binding energy in the boron channel and reaction rate, ultra low T9. The higher channel binding energy, the higher reaction rate, the regularity is following. We analyze the boron isotopes as we do it in the previous boron. Here it's a table view of radiative capture reaction of the boron isotopes in the modified potential cluster model, which we done in the previous year. And also based on reaction shows we also calculate the ignition value, which depends on the neutron number density and temperature. The T9 interval relevant for the start of air production of foreign bore may be defined as the present stage under the neutron density matter condition should be following. And here it's important to stress that the dependence from the temperature and the neutron number density has a reverse dependence from each other. There is some conclusion and prospects. The total cross-section for the boron 13 calculated in energy range from 10⁻2 up to 5 MeV. The reaction rate process shows the same dependence on the asymptotic constant. We also declare that the present data of reaction rate plays the substantiate role in the boron carbon nitrogen chain, and this is a not breakpoint of boron sequence. And this conclusion and prospect correlate with the defense of provision 3. And the last one is a revision of nitrogen 15 in modified potential cluster model. The revision of nitrogen 15 plays a key role in solar and stellar carbon nitrogen oxygen cycles. And there are a lot of efforts to calculate the experimental data and find the astrophysical S0 factor. But it's everybody knows that we can't measure it's impossible to measure the directly astrophysical S0 factor. This is a slight variation of this consideration. But what is important here, this is the first time when we taking into account the M1 transition in our consideration. A lot of scientists want to predict a zero factor. As you can see, our present research is in a good agreement with, for example, Muhammadjanov, with Son. And the next question which we have is, what is the contribution of each transition to S0?
Sorry, you have only 1 minute.
Okay. Factor. We have here the contribution of each transition. For example, E1 has 41, E1 10%, M1 is 7%, and we see that the biggest contribution to the astrophysical S0 factor are coming from the interference. As I said in the previous slides, for the nitrogen isotope, we also have the same regularity with the binding channel energy and the reaction rate. The higher channel binding energy, the higher reaction rate. Exception is nitrogen 40 due to the E2 capture contrary. We also simulate that in our consideration the cascade transition. The dependence of the ratio of the total reaction rate, which is assumed of contribution from the ground state and cascade transition of the following reaction rate to the ground state on temperature. And the most, if we see on the graph, the most strong cascade transition input at T9 equal approximately 1 and 1.9. It's about 25-30%. But what is important here, this is not a CNO cycle anymore. It's not the region of the CNO cycle. The conclusion and prospects is following. The interference of the S wave resonances lead to the significant increase of S factor energies up to 30 keV. To evaluate the impact of cascade transitions, the model calculation for the interference of a strong demand, we find the regularity between the threshold binding energy and the reaction rate here. Let me turn to some research approbation and publication. I have got all my dissertation work consists based on the 4 published articles. The first one is published in Frontiers in Astronomy and Space. The other 3 articles published in Chinese Physics C with my scientific advisors, and also with Dubovichenko Sergei Borisovich. Thank you for your attention.
Thank you for the presentation. Let us now proceed to the question and answer session. Dear members of the Dissertation Council, do you have any question for the candidate? Please.
Good afternoon. I have a question. Can I?
Yes, of course.
Badagul Maratovna, according of the revision of nitrogen 15, can you please suggest why it is important to know the astrophysical S0 factor? Thank you.
Thank you for the question, Gauhar Danilovna. The astrophysical S0 factor, as I said before, it's very important to determine it because of the because it's described and predicts the rate of nuclear reaction at low temperatures, at low temperatures occurring at low temperatures. And it's important to stress that we can't measure directly S0 factor, astrophysical S0 factor, because the energy corresponds to the zero interaction energy. And here it's important to stress that to measure the astrophysical S0 factor, we usually measure the first time the astrophysical S factor at higher energies where the total cross-section can be measured. And then we use the theoretical model approach, which can be, for example, modified potential cluster model or the air matrix approach, and then extrapolate this astrophysical S factor to the zero energy range. Then we have the not directly measured astrophysical S0 factor, but inferred from the theory.
Thank you. Alia Nurmambetova, your question, please.
Thank you very much. First, I would like to thank Badigul for this nice presentation. I really enjoyed. And I have several questions. Maybe we can start with first one. Badigul, can you go to the slide 9? I guess there is a problem because we don't see your pointer. So that's why maybe I have some simple question for you. So when we go to the slide 9,
Yes. Oh, 8. Sorry, one just. Mm-hmm.
oh, no, I'm sorry. I guess it should be slide 7 in that case.
Yes.
Oh, yes, this one. Okay. So my question is very simple. I just want to know. So there is in this slide, we seen the some reaction rate of different authors in your calculations.
Yes.
So so can you give some maybe brief explanation why your calculations are a bit different? I'm curious about the McLarkin because I guess he used the same type of let's say addings for calculations. Because his line goes down a bit, and your lower is a bit cross section. It's a line is going a bit upper. So can you explain that?
Thank you. Okay. We see the great difference in the reaction rate. I've started from the T9.
Excuse me?
Okay, sorry. Here we assume that the reaction rate started to rise at T9 equal bigger than 1. We see that can you see the?
Yes.
Yes, okay. The main problem of this, the difference between reaction rates from the ab initio reaction rate, Donk, McCracken, and our present work, that because we variate the asymptotic normalization coefficient. That's why we have here the pale band. As I said in the previous slides, we find the regularity. That's because it means that the reaction sits between this region. And also the main difference between our consideration with other model approach, it's because we used different types of the models in our, it's theoretical calculation, but different in, it's different models.
Okay, thank you. If it's possible, may I ask one more question?
Yes,
on slide 12?
12?
Slide 12, yes. So in this slide, slide 12. I'm sorry for this. Yes, okay. So in this slide, you mentioned that this is different of let's say shoulders between the in this line is that you are added some resonances. Yes,
Yes.
yes. Could you please tell what kind of resonance you are talking? I mean, what kind of resonance you added? Yes.
We can see it from this picture. It's a
Mhm.
spectrum level of the beryllium-10 nucleus.
Mhm.
Here you can see that this is a bound state of first excite. I'm sorry. This is a bound state, and this is a threshold energy. And then on the spectrum, we see that this is resonances, 5 resonances, which we can see on the spectrum, but we don't know the main configuration of this spectrum.
Okay, but what I'm seeing is the six of this resonance, and what kind of one of the main resonance gives so the big effect on threshold?
The biggest one is the first and second resonances.
So when you said the first and the second, you say about 7.3 MeV or 3.5 MeV or 10.5. What do you mean?
I mean this one.
These two ones. So it
Yes.
means that 3 minus and 2 plus gives so big threshold. Okay, a big shield. Okay, thank you.
Thank you. Dr. Vasilevsky, please, your question.
Thank you. First of all, my congratulations with very good presentation of results obtained. I have 3 questions to clarify method you used and your results. The first question is connected with your table 2.2 in your dissertation. It's as I am correct, page 18 or so. What we know, if we use, if we consider interaction of 2 clusters with non-zero spin and non-zero angular momentum, then interaction with aligned states with maximal total momentum is larger than other in other states. However, in your dissertation, there is no such a correlation with of intensity of your potential with, for example, width and energy of resonance states. The first question, why you have such unusual, from my point of view, results for your parameters, and maybe sub-questions to do the first question, why do you use different radius of your potentials? Do you follow my question?
Yes, the table number 2.2, it's a lithium, formation of primordial lithium 8, yes?
Yes, well, in the dissertation, it's potentials, parameters of potential for system neutron plus 8 lithium.
Yes.
So in other words, I expect that for states with largest total momentum, the intensity would be the largest, and so on.
Yes. The table which you mentioned above is includes the parameters of interaction potential for the following continuum. And here with the main question, why we use the different radius for our potential. When we
Mhm.
when we used the modified potential cluster model, we used such parameters like asymptotic normalization coefficient, charge and matter radii, and also the gamma widths and the channel binding energy. And as I presented below, we used the formula which the following formula to calculate the total cross section. And here the main part that we fix the gamma and then we just varying the parameter of potential. The main
Gamma, sorry, gamma, you mean width of resonance states or what gamma?
the parameter, gamma parameter. We just fixed it, gamma quantum, and then we just varying the parameters of potential. That's why we use different types of radius.
I see. Okay. The second question, it's actually not a question. I need a piece of advice. I am going to calculate with my colleagues reaction rates. So my question connected with calculation of this value. What energy range do you use to calculate reaction rates, and how did you check convergence of these results? You can open your slide number 12. Yeah, this integral that you have here.
We used the different energy range for the each reaction, which I included to my dissertation work. It's about 10 minus 2 up to 5 MeV. Of course, it's low temperatures, it's low energies, and all our calculation are made by using this simply Fortran. We just fix the parameter and then varying the to calculate the total cross section, and according to the calculated total cross section, we just find the reaction rate.
I see. Okay. The last, my question connected with your dissertation, page number 75. You have a very interesting figure. You numerously demonstrated that resonances leads to the rapidly or slowly increasing of phase shift as a function of energy. But on the figure 5.5, you demonstrate some kind of anti-resonance behavior of phase shift. It's not growing, it's going down, decreasing.
Yes.
Why is that?
It's because this part is the picture is provided to the nitrogen 15 isotopes, and here we also talk about the astrophysical S factor. As we know, the astrophysical S factor has a very high dependence from the total cross section, and it becomes very small, very small. It's hard to analyze such kind of reactions with such kind of big dependence from each other. The main reason is because sometimes it's a column barrier, some tunneling effect, and so on. That's because we used the astrophysical S factor, which give us the possibility to extrapolate the obtained data. And here on the graph, we see that it's dependence from the between the total cross section and reaction rate.
Well, actually, I asked about a little bit different about phase shift, not S factor, because it's strange to see that at resonance energy you have rapidly decreasing phase shift. Okay, so thank you very much.
Thank you.
For your answers.
Thank you. Any questions? Okay.
What energy region to influence at CNO cycle?
10 minus 2 up to 10 5 MeV.
Minus 2 MeV? Minus 2 MeV?
Yes.
Approximately. And your resonance are in the energy.
Yes.
Colleagues, do you have any further questions? No more questions? If there are not no more questions, we will move on the next stage. The floor is given to the local scientific advisor, Doctor of Physical and Mathematical Sciences, Professor of the Department of Theoretical and Nuclear Physics at Al-Farabi Kazakh National University, Burkova Natalia Alexandrovna.
Thank you very much. Dear colleagues, let me be very short in my characteristics of the done work and also my doctorand Елеушева Б.М. So if in 2 words is nutshell, good job, well done, and very there are a lot of perspectives for continuing in future. I appreciated these results as the most important ones. So I think that Badigul really succeeded with all tasks suggested for a solution, first of all, but she also demonstrated herself as excellent team worker. So as on the all stages of implementing the work, she asked so many questions, what to do, why, and why not, and etc. So that I think that this is a promising for future intensive scientific research career of my applicant. And so finally, I think that the results obtained and suggested for the discussion, I think they fully comply with the requirements for the demands of the dissertation for doctorate of philosophy, and Badigul Yelosheva undoubtedly deserves the award of the degree of Doctor of Philosophy. So my kind request supports this suggestion from my side. Thank you very much.
Thank you, dear Natalia Alexandrovna. The floor is now given to the foreign scientific advisor, Doctor of Physical and Mathematical Sciences, PhD, Professor of the City University of New York, Kerezashvili Roman Yakovlevich. Please.
Very good morning to everyone from New York, and thank you for this opportunity to say a few words related to the dissertation presented right now to scientific council. So the topic of dissertation is interesting enough, very timely due to current experimental and theoretical research at low energy nuclear astrophysics and, to explanation of nuclear synthesis in the universe. So basically work is clearly communicated. Dissertation is written in clear and understandable style. I believe you have been all witnesses to today's presentation, how logically the dissertation was, your presentation, Badigiul's presentation was structured. All figures tables show given in dissertation demonstrated result of sometimes very complex calculations. So to sum up all this, I will say dissertation presents a good level of scientific work with scientific novelty and intensive research ranges. Some personal impression. During the conducting research, Badigiul has established herself as young, competent scientist who able to independently solve scientific problem assigned to her. Badigiul proved her excellent analytical skills. High quality of her work demonstrated that all papers have been published in peer-reviewed journal. In other words, the expertise went also not in some publications which are not referred, but through the very respectable journals with a high citation rate. So the other things is that she also make her presentation on the International Conference on Few Body Physics in Mainz, Germany, and her presentations there attract interest by discussion after her presentation. To conclude, I strongly believe that dissertation fulfill all requirements posed to the dissertation of Doctor of Philosophy, and research conducted by Badigiul and presentation presented in her dissertation is on cutting edge of low energy nuclear astrophysics. In her dissertation, Badigiul has demonstrated her creative ability. It's number one, I will say, in relevant research of area. Of course, I strongly recommend the dissertation thesis to be awarded and she should be granted by degree of Doctor of Philosophy in specialty of nuclear physics. Moreover, when she was visiting in New York, she demonstrated, not only curiosity with respect to physics, but also with respect of history, with respect of her interest to the cultural difference in different countries. And I believe, she is very talented and she has a wide avenue for her development in the future. So she is independent thinker. This is very, very important. I believe now she able to, by herself, create the research topic and solely able to solve this research topic. I strongly recommend her for the degree of Doctor of Philosophy. Thank you.
Thank you. Now the floor is given to the official reviewers. The floor is given to PhD, postdoctoral scholar of energetic cosmos laboratory, project group at Nazarbayev University, Nur Muhammedova Aliya, please.
Thank you very much. In short, all my revision I presented to the committee. And just would like to say that it's very nice work, and the results are really good and presentable. So we had some concerns and some questions with Badigul about the calculations, about the resonance, how this resonance affecting of it, and all these questions we saw during the communication during my reading your PhD reading your PhD dissertation. And finally, I would say that I really support this work, and ask for just to congratulate here with very nice done work. That's it.
Thank you. The floor is given to Eleusheva Badigul to respond to the reviewers' comments, recommendations.
Thank you for the feedback, Aliya Kinjikaliyevna, but there is no any notes from her.
Thank you. The floor is given to PhD, senior lecturer and at the Department of Nuclear Physics, New Materials and Technologies, Gumilev Eurasian National University, Temirbayev Azamat, please.
Thank you very much. Thank you very much. Good afternoon, dear members of the Dissertation Council. Let me read out my review of the dissertation work of Eleusheva Badigul-Maratovna. The topic, radiative capture reactions on light nuclei in stellar and interstellar plasma, presented for the PhD degree. And the topic, first of all, the topic of the thesis corresponds to the priority directions admitted by the High Scientific and Technical Commission of the Ministry. And this thesis was completed within the framework of two scientific projects. The importance of this thesis for science is very high, I think, because it makes a significant contribution to nuclear astrophysics, nuclear synthesis, and also to the physics of exotic nuclei, as it considers nuclear reactions of formation of such neutron-rich isotopes as lithium-9, beryllium-10, and boron-14. Using, we can say, a new method, modified potential cluster model. And also, of course, those nuclear reactions, they are very important in nuclear astrophysics for lithium, beryllium, boron problem. Maybe they will be able to help to solve this problem. And also the reaction of formation of oxygen is one of important nuclear reactions in CNO cycle. So that's why it is very interesting to see how a modified potential cluster method can affect this reaction, the results of this reaction. Also, this thesis is very actual, very important, because, of course, here we should use resonance states during the calculations of cross sections, and this was done for reactions of formation of beryllium-10, and of course we cannot deal here without resonance states. So that's why this makes the importance of the work higher. Then previously we said that this work was completed within the framework of two scientific projects, but nevertheless, here we state that this work corresponds to the principle of independence. That is, it is an independent and self-reliant work. Also, the work corresponds to the principle of internal unity, because the content, the purpose, the objectives of the work correspond to the topic of this work. The relevance of this thesis was justified, especially in the introduction part of the thesis. All parts of the thesis are completely interconnected. And the connection point again, that was a modified potential cluster model. And everywhere in each part of the work, there we can see a critical analysis of the results of the methods used in the calculations. And also here we can see that the results, according to this critical analysis, the results were compared with available experimental data available on the day. Then the scientific novelty principle, the thesis totally corresponds to this principle, because all the provisions and corresponding to those provisions, the results and the findings of the thesis, they are totally new, taken into account the methods used plus nuclear reactions considered and plus energies at which those nuclear reactions were considered. So that's the validity of the main findings. All the main findings of the work, they were found with calculations, with exact theoretical calculations. So that's why the validity of the main findings is out of any doubts. Then all the provisions of the defense, they were proven in the thesis. They were not trivial, they were not obvious. So that's why the thesis needed very strong theoretical calculations, and we could see them. Then all the provisions are new again, and the application level of the provisions and the results. Well, if we take only nuclear astrophysics, then the application level is very high, according to the scientific importance of the thesis. But in my review, I noted that for physics in general, application level is medium. But I mean that for nuclear astrophysics, the application level is very wide and very high. The reliability of sources used in the work, again, they are very high, and you can see it in the corresponding part at the end of the dissertation thesis. So the choice of methodology, it was presented in the presentation, and you could see that really this methodology, that is the modified potential cluster model, it is a very interesting model, and interesting and modern, one of the modern methods. And all the results, they were confirmed. They were confirmed by the corresponding references. The corresponding references. And now the practical value. The practical value. This thesis, first of all, has the practical importance because the results of this thesis, they can be used in nuclear synthesis to evaluate or re-evaluate the percentage of the nuclear isotopes in the universe. And also, of course, it has the theoretical value because the results of this thesis can be used in the following calculations. And I have noted that there is practice suggestions in the dissertation thesis, because this thesis suggests to imply the results of this work for Isolde project. And now, the last technical, well, academic writing. The academic writing quality is very high, and it was noticed by other participants. And the scientific level, again, it is high, and again, you have noticed it, because there were a series of high-quality scientific publications in the corresponding high-quality scientific journals, and they entered such a scientific base as Scopus, for example. And the decision of the official reviewer, the work of Eleusheva Badigul-Maratovna on the topic radiative capture reactions on light nuclei in stellar and interstellar plasma, submitted for the PhD degree in the educational program nuclear physics, meets all the requirements and is deserving of being considered to be awarded the academic degree of Doctor of Philosophy, PhD. Thank you for your attention.
Thank you. The floor is now given to the candidate to respond to the reviewers' comments, recommendations, please.
Okay, Azamat Aliyevich, thank you very much. You have got a notes in your reviewing a letter. It's connected with that it's possible to need any general section with which will include all the reactions which I described in my dissertation work. And my answer is that while we developing the structure of my dissertation work with scientific advisors, Roman Yakovlevich and Natalia Alexandrovna, we repeatedly discussed this part, and however, we decided to address of each problem relevant within the section. It means that all my sections in dissertation work has a preface which includes literature observed, literature research, experimental measurements for today, as well as model calculation with other different approach. And the second note connected with research methods, if I remembered, it's if briefly, our first section is called the MPCM, Modified Potential Cluster Approach, and description of radiative capture reactions, neutron and proton-induced. Here we have two subsections, which one is totally entirely devoted to the calculation methods of the radiative neutron capture, proton capture reactions. And that's it.
Thank you very much for your answers.
Thank you. Dear colleagues, may we now begin in the open discussion of the dissertation. In your speeches, please address to the dissertation's compliance with the principle of independence, internal consistency, scientific novelty, reliability, particular value, and academic integrity. Who would like to speak on this dissertation?
I would like to make one note. Dear colleagues, I would like to pay attention or pay focus on 3 slides which have been demonstrated first time here on this dissertation defense. These 3 slides related to correlation between binding energy and reaction rate for isotopes of lithium, boron, and hydrogen. You know, this is the first time where such kind sum up is given, and all this given within the same modified potential model. You know, this is first time mentioned, and I believe this is very puzzling and interesting, not topic, I will say, interesting question, which should be motivated to study such kind correlation, not only within a modified potential model, but with an ab initio calculation, for example, or the other model. Thank you.
Thank you. And Pazal, please. Microphone, please.
Okay. I think it's a very good dissertation, and but I have some. Okay. Sorry. I would like to ask. No, ask. It's maybe some my opinion about research approbation and application. You have some good publication. Main result your thesis were publication in good foreign scientific journals, but I would like some my opinion. Some did you publish in Kazakh journal?
Yes, it was Al-Farabi Aleva. It's yes, my university.
It's only international conference. Yes, and maybe you have
just conference, but no local scientific journals. But now we prepared one article for the Vestnik. Vestnik, do you know? Yes, yeah.
Okay.
It will be local.
Nevertheless, it's very good dissertation and so on.
Thank you, Professor Lebedev, and thank you, dear colleagues. Are there any others who want to say something? If not, let us now proceed to the secret voting. The scientific secretary will now send an voting link to your emails addresses. Please follow the link where you will find 4 options for the discussion. First, to award the degree of Doctors of Philosophy PhD. Second, to send the dissertation for revision. Third, to send the dissertation for re-defense. Fourth, to refuse to award the degree of Doctors of Philosophy PhD. You should choose one of the option listed and vote.
Yeah, please 1 minute. I will send the link for voting. 1 minute. Нет, сейчас. Я разрешение дам, надо открыть. Сейчас минутку.
Just need, please.
Okay, dear members, now you can open your emails and link for the secret voting were sent for you. Please vote. Gmail добавить тоже?
Sorry, I have already voted. Should I vote again? I just have voted.
Wait, please. Wait.
Mm-hmm.
Yeah, I also received several invitations,
Yes.
and I use only one.
Yes,
From
yes,
three.
you should wait only once.
Mhm. Okay.
So, Yulia Iratovna, can you see my results on the votation?
I can see this is a secret voting. 1 minute, please.
Ah,
Так. А у меня тоже что-то Google. Не так где. Почту дошел, вот сейчас что-то вылезло.
А, еще.
Финал оформлен. Привет, письмо. Сейчас. Вернемся. Вот.
Вот. Смотрите. Нет, вот сюда.
Вот я и нажимаю, она вот что вылазит. Вот.
Странно, а у меня без проблем.
Пошло. Все, мне пошло. Все, спасибо. Угу. Так, итоги голосования. Нет, не все еще. Ага.
So we are waiting. We should give some time for members of the dissertation council to wait. Now, 1 minute, please. We are waiting for 2 voices also. One minute, please. We are waiting for one voice. Yes, now it's okay. And 1 minute, please. All members of the Citation Council have waited. I will start screen sharing now. So the result of the voting on the award of the degree of Doctor of Philosophy. 1 minute, please. This one. Okay. Can you see? Okay. Now the 9 votes we get. So it's 100% for award the degree of Doctor of Philosophy. So the results of the voting on the award of degree of Doctor of Philosophy indication programs AD05308 nuclear physics to Елеушева Бадигуль to award the degree of Doctor of Philosophy 9 votes. Now I will also demonstrate the table. 1 minute, please. So in it showed the time range of the voting member of the Citation Council. Okay. And their chosen response. So now you can see here that. Wait, sorry. It's okay. Now you can see here that it's 9 votes. Here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 votes to award the degree of Doctor of Philosophy. Thank you.
Thank you. According to the decision of the Dissertation Council for the specialty educational program 6D06250 or 8D05308 nuclear physics in the training direction, 8D053 physical and chemical sciences, format at NPGCS, Alfa Arabi Kazakh National University and Institute of Nuclear Physics. Елеушева Бадигуль Maratovna is awarded to the degree of Doctor of Philosophy PhD in the educational program 8D05308 Nuclear Physics. Congratulations. The floor is given to Елеушева Бадигуль Maratovna for her closing remarks. Please.
Thank you so much. I want to express my words of gratitude, first of all, for the Dissertation Council members. Especially, I want to say many thanks to the Penkov Fyodor Mikhailovich for your comments, reviewing my work or in extended meeting previously. And of course, I want to say many thanks to Zaripo Yulia Iratovna for your patience due to the while we present all the document processes. I'm grateful also for the temporary members of dissertation councils, Lebedev Igor Alexandrovich, Viktor Semyonovich, Gauhar Danilovna. Thank you for your quick feedback, for your constructive comments, and for your openness. Also, thank you for your guidance and support. And of course, I want to say the grateful thanks to my scientific supervisors, Professor Burkova Natalia Alexandrovna and Professor Kizirashvili Roman Yakovlevich. Many thanks for your guidance and support, for your mentorship, for your dedication, for the your enhanced influence for my academic growth. Many thanks to the Roman Yakovlevich for the wonderful journey in New York. Thank you so much. And I want to also say the words of gratitude to my official reviewers, Alia Kinjigalievna and Azamat Aliyevich. Thank you so much for your quick feedback, for your constructive feedback, for the comments, for the notes, for your openness, guidance, and support through these months while you are writing my review letter. Thank you so much.
Well, dear colleagues, we now left to adopt the council conclusion of dissertation of Elieушевой B.M. The draft conclusion and classification criteria for the dissertation have been distributed to send to all council. All council members, please open the document and let's begin our discussion. Are there any comments and suggested conclusion?
I have one technical remark, if I may.
Yes, of course.
There is an abbreviation in this document which not explained. It's not very good for such type of document. So when it's first time used MPC, MPM abbreviation, it should be explained what does it mean. Thank you.
Viktor Semyonovich, thank you so much for your feedback today. Nasrullah Tokanovich said about it to me before the meeting started. I will change it, and thank you.
Okay, you're welcome.
Congratulations, Bodigul. Now I have to leave. I'm sorry. Thank you, everyone. Have a wonderful evening, wonderful day in Europe, wonderful evening in Asia, and now in our new world in US, we have a morning and I have to go to the work. Bye-bye, everyone. Thank you. Congratulations.
Goodbye.
Thank you very much. Okay, Viktor Vasilyevich. Okay, Viktor Semyonovich, thank you.
Are there any comments and suggestions? Предложение? Заключение. Можно голосовать. Давай. Так. as a member of the dissertation council to vote on the approval the conclusion. Who is favor approving the draft conclusion? Please vote. Who is? Please vote.
Dear members, just hand maybe. Aliya, Azamat, Gauhar. Thank you.
Who is against? No one. No one. Who is abstained? No one. It's approved unanimously. Thank you. Так, что у нас еще? I would also like to thank everyone for their work, and with that I will conclude our session for today. Thank you all for your work. With the meeting of the dissertation regards of the defense of the Yulia Elesheva B.M. dissertation is declared closed.
Thank you very much for your time and the work.
Thank you. Congratulations.
Congratulations, congratulations, and good
Thank you
luck.
so much.
And good luck.
Thank you.
Okay.
Miruert,
Ciao, ciao.
goodbye.
Goodbye.
Miruert,
Goodbye.
да, можете остановить запись. Сейчас Miruert выключит. Сейчас я позвоню, она трансляцию установит. Можете звук выключить.